In section 3.2, we now discuss measures of variation. The first measure of variation is the range. The range is the difference between the highest and lowest values in a data set. So we can write the range as the maximum value minus the minimum value. Here's an example. The manager of an electrical supply store measured the diameters of the rolls of wire in the inventory. Diameters of the rolls in meters are listed below. Compute the mean and the range by hand. So let's grab our calculator. To first calculate the mean, we're just going to add these numbers together. We get 2.874. And we need to divide by the number that we have. We have 7 rolls. And so our mean for the diameters of the rolls is 0.4106 meters. Notice that our data has 3 decimal places. Our measure of center has 1 more decimal place than our data. And then to calculate the range by hand, we scan this for the biggest value, 0.668, and the smallest value, 0.139. And if we subtract those two, we get 0.529 meters. And that would be our range. The range is a very simple calculation, so it has its advantages, but it also has its disadvantages. Because we're using the maximum and the minimum, the range is greatly affected by outliers. Our next 2 measures of variation each come with 2 different forms. One when we're working with population data, and one when we're working with sample data. We have the variance and the standard deviation. The variance and the standard deviation are very closely related to each other. The standard deviation is actually the square root of the variance. The population variance is the average of the squares of the distances each value is from the mean. So the idea behind the variance is we take each of the data values and subtract the mean, then we square that difference, add all of them up for all of the data values, and divide by how many data values we have. So it's the average of the squares of distances each value is from the mean. And we have formulas for the population variance and standard deviation, but we're going to be looking at using technology to calculate these values. Pointing out a couple of important symbols. The symbol for the variance is another Greek letter, and this Greek letter is the lowercase sigma. Sigma looks like a circle or an O with a little hat on top. And the population variance is sigma squared. So we definitely have this square on the sigma. If you notice down with the population standard deviation formula, the inside of the formula looks exactly the same as the population variance formula. We just have a square root on it because that's exactly what the population standard deviation is. The standard deviation is the square root of the variance. And these 2 measures of variation tell us how spread out the data is on average. Because we are considering every data value and its distance from the mean, we're looking at all of those differences and finding an average difference between the data values and the means. And then for sample variance and sample standard deviation, we have the same idea here. This formula is if you're doing it by hand, which we generally don't do. And the standard deviation for a sample, notice the symbols used now are S. S squared for sample variance, S for sample standard deviation. And again, to find the standard deviation, we just take the square root of the variance in either form, whether it's population or sample. If it's a parameter or a statistic, it doesn't matter. And the purpose of computing a statistic is ultimately, other than just to summarize our sample data, we're going to use that statistic to estimate a parameter. The formulas for population and sample variance are very different, so it is important that we know whether we're working with a population or a sample. The vast majority of the time, you'll be working with a sample. So here's an example. The following is a random sample of life expectancies in 2020 for 10 different countries. Use Excel or Google to compute the standard deviation. Here's another example where Excel and Google will actually lend the same steps. I'm here in Excel and I'm going to just enter my data. And I want to calculate the standard deviation or the variance. Let's start with the variance. So if I type in VAR, I have options. And the first two that come up, var.p and var.s, are the two formulas that we'll be using. var.p stands for population variance, it's a parameter, and the var.s is our sample variance. We are given only 10 countries, so this is a sample. We're going to move down to var.s. And I will select my data and hit enter. And my variance is 41.04. I can move my decimal so that I have the right number of decimal places. And I know the problem says to compute the standard deviation, and I just did the variance. I really just want to show you the connection between the two. So for standard deviation, we're going to start by typing STDEV. So standard deviation, STDEV. And again, we have those same options, .p, .s. This is a .s for a sample. I'll take the values, put them in the formula, and I'll get my standard deviation. And I can move my decimal places over so that I can see only 2 decimal places. Showing you the relationship, I'm going to type square root. You won't have to do this, but again, I'm just illustrating the relationship between the variance and the standard deviation. If I take the square root of my variance number, I should get the same value as my standard deviation. And just to illustrate that, expanding out the decimal again, I have the same number here. So the square root of the variance is the standard deviation. Google's commands are exactly the same. So we have standard deviation. We're going to use S because we have a sample. And these are in years, life expectancy in years, so our standard deviation is 6.41 years. We do have to be really, really careful because for the variance, the units are actually square years, which seems a little strange because it is. We're squaring the differences, so we end up squaring that unit as well. So since variance has this very strange squared units, we usually don't talk about variance with its units. But there we have our standard deviation and our variance. The formulas are here only for your convenience to know that they are pretty crazy formulas. I will not expect you to calculate these by hand. What I want you to know from them is that standard deviation is a measure of how spread out the data is on average, and the variance is the square of the standard deviation.